All right, so if you've ever written more than a few lines of code, you've probably run into two, let's call them classic problems. First, your code just breaks out of nowhere. Second, your beautiful, simple script starts to grow, and suddenly it's this giant, tangled mess that you can't even stand to look at. Sound familiar? Well, today we're going to talk about the two absolute keys to getting past those problems. We're going to learn how to teach our code to fail gracefully and how to keep it organized so it doesn't collapse under its own weight.
So let's start with that first problem, when things just go wrong. And I mean, we've all been there, right? You're using an app, you're on a website, and poof, everything just dies. But here's the thing, the way it breaks, that's what really matters.
Think about it. You've definitely seen both of these. On one hand, you get that ugly, cryptic error message. The whole program just crashes and burns. It feels like the computer is yelling at you, right? It's just frustrating. But then there's the other option. You get a nice, clean page not found. The program still failed, yeah, but it failed politely. It told you what went wrong, and it didn't just give up on you. That right there, that's the difference between an amateur app and a professional one.
Okay, so how do we actually do that? How do we get our code to fail politely instead of just, throwing a tantrum and crashing? Well, it all starts with accepting a very simple, very important truth. Your code is dumb. Like, really, really dumb. It has zero common sense.
I love this analogy from the source material. It's perfect. Imagine your program isn't just code, it's a company with 10,000 employees. And every single one of these employees is extremely literal. They'll do exactly what you tell them to the letter. But the second something unexpected happens, they completely freeze. They have absolutely no idea how to improvise.
And that's exactly what a program crash is. Just one tiny little problem, maybe a user typed an A where a 1 should be, and the entire company of 10,000 employees just stops dead in its tracks and comes crying to you, the boss. It's a total shutdown. So yeah, we need a way better way to manage these guys.
The solution is to give our little employees an instruction manual, a what to do in an emergency guide. In programming, we call this error handling. And in Python, our go-to tool for this is a really simple but super powerful little concept called try and except.
And the idea is so simple, it's brilliant. It's a two-step plan. First, you take the piece of code that you think might cause a problem, the risky part, and you put it in a try block. It's like telling Python, hey, give this a shot, but be careful, it might blow up. And then, right after that, you write an except block. This is your plan B. It's the code that Python will run only if that try part fails.
Check out this super clear example. On the left, we have some code that asks for a number. But of course, the user types in the letter A. The code has no clue what to do with an A. So, boom, it crashes. The whole thing's over. But look at the right. The programmer was smart. They thought, hey, what if someone doesn't enter a number? They wrapped their code in a try-except block. So now, when the user enters A, instead of crashing, the program just says, whoops, only numbers are accepted. See? No crash. That right there is you, the developer, taking charge and making sure the user has a good experience even when they make a mistake.
Okay, fantastic. So now our code is crash-proof. We're amazing. But as our program starts to get bigger and bigger and more complicated, we hit that second wall I was talking about. And that wall is just pure, unfiltered chaos.
I mean, seriously, can you imagine trying to read a 10,000-page book that has no chapters, no table of contents, no page numbers, just one giant wall of text? That's what your code becomes if you just keep adding to it in one single file. Trying to find anything is a total nightmare, and worse, when you try to fix one little bug, you end up creating 10 new ones by accident. It's not sustainable.
So, what's the answer to all this mess? It's simple, really. Organization. We need to give our code some structure. And in the world of programming, the best way to do that is by using something called modules. So what is a module? It's actually ridiculously simple. A module is just another Python file. That's it. But by putting our code into different files, we get to be like an author writing a book. We can create different chapters. Maybe one chapter handles all the user login stuff. Another chapter handles talking to the database. Each one has a clear job, which makes the whole program way, way easier to understand and work with.
And I mean, look at the difference here. It's like night and day, isn't it? On the left, you have that single, giant, messy file, that unreadable scroll we talked about, and on the right, you have a nice, neat bookshelf. Every book has a clear title,
userlogin.py, database.py, API requests.py. You know exactly what each one does, it's clean, it makes sense, and best of all, if something goes wrong in the user login book, it's not going to bring down the whole library.
And here's the really cool part. Python already comes with a ton of these modules built right in. The math module is a perfect example. Let's say you need to use pi in your program. Are you going to type out 3.14159 yourself? No way. You're just going to type import math, and then you can use math.py anytime you want. It saves you time, it means you can't make a typo, and it just makes your code so much cleaner. You're reusing work that someone else has already perfected.
Okay, so let's tie all of this together. We've talked about handling errors and organizing code. Let's see how it works in a really simple, fun example. We're going to build a basic joke bot.
All right, so here's how it goes. A user comes along and sends a message to our bot. They say, "Tell me a joke."
Now, the logic inside our bot is super simple. It just asks one question. Does the message I just received contain the word joke? And in this case, yeah, it totally does.
And because the answer was yes, the bot does its thing. It tells its one and only joke. Pretty straightforward, right? But what happens if the user asks something completely different?
So this time, the user asks, "What is your name?" Now, our bot has no idea how to answer that.
But it follows the same logic. It looks at the message, "What is your name?" and it asks itself that same simple question. Does this contain the word joke? The answer, obviously, is no. The condition isn't met.
So because that if statement was false, the code jumps to its backup plan, the else block, and it gives a nice polite response. Sorry, I only tell jokes. Now, even though this uses if and else, it's the exact same idea as try and except. You, the programmer, anticipated something you couldn't handle, and instead of crashing or just staying silent, you provided a safe, helpful alternative.
So really, it all boils down to these two crucial takeaways. First, handle your failures gracefully. You have to assume things will go wrong, so use tools like try and except to build a safety net and prevent your program from crashing. And second, organize your complexity. As your code grows, you absolutely have to break it down into smaller, manageable chapters using modules. You know, mastering these two things, handling mistakes and staying organized, this is what takes you from being someone who just dabbles in scripts to someone who builds real, solid, professional software. They really are the keys to building anything great, anything that lasts. So the only real question is, what are you going to build?